Good morning, good afternoon, good evening. Welcome to Hands-on SAP Dev with me, QMacro. I've just noticed, I've just noticed that Robert Dino said nice cough. I didn't realize that the audio mixer was on the standby screen and me typing and everything. But yeah, I guess you can tell that this is how it works. The few minutes before go live, I'm thinking, now what am I going to do? Just make sure I clear my throat and everything. So thank you for letting me know that you can hear me. That was very, very nice and subtle, very, very gentle and kind. So it's a very cold and frosty morning. Well, I mean, not very cold. It's only -1 here, -1 degrees Celsius. Defrosted the car, scraped the car for my wife this morning before she went out. I can see the chat here. I'm using, as I've used for a couple of times before, mostly for test purposes, I'm using this new streaming software called Lightstream, which is available basically in your browser. It's crazy, crazy good. It restricts me at the moment to 720p, but I think that should be good enough. I've adjusted my monitor and everything. Let me just move this slightly up. There we go. Yes, there we go. Yes, we are kind to each other. Exactly, Robert. We are kind to each other in the hands on SAP Dev Family. Excellent. So good morning, Robert Dino. Good morning, Chris. -2 down further south, I guess. That's interesting. And good morning, Helmut. So great to have you on board. We're going to do about, as I mentioned briefly yesterday, I plan to do about 90 minutes, so an hour and a half. So hopefully that will mean that I talk more slowly and we can take our time with various things. By the way, can you also see, I think you can, yes. I'm looking at the video preview up there. You should be able to also see the chat as normal. Okay, this should look fairly similar. This should look almost the same as how I was streaming when I was using OBS. Lightstream. Maybe we'll talk about that in more detail on another stream. But one of the amazing things is that I was trying to figure out why can I do this on my I'm on my Chromebox. Okay, which this particular Chromebox I think has 4 gigs of memory, and I don't know what CPU it is, an i5. So it's not super powerful, but the fan's not going crazy and so on. And it's because the encoding is happening in the cloud. So Lightstream have these encoding servers in the cloud, which is pretty freaky, pretty amazing. So let's see how it goes. And if this goes well, then I'm going to be using this in the future. Good morning, Srikanth. Awesome hardware hacking on your part, by the way. I love the what do you call it? The number flip mechanism. Really, really nice. Post a link to that on the chat here. Flip flap display. That's it. Flip flap display. And good morning, Mahesh. You know what? It's so awesome to now be broadcasting live here on a Tuesday after TechEd in Bangalore, having met so many of you last week. So, for example, Mahesh, I know that Napit, whom I also met for the first time, is on holiday now with his family in Goa. So I guess he's not going to be around. But that's okay. We've got some amazing people here. I think I've met everybody else I've met, right? Face to face. That's great. Or at least, sorry, everybody else who's typed in the chat. I can't see exactly who's on there. But welcome. So, as the episode description stated, we're going to talk about functional programming techniques. Ronnie, so your MacBook Pro i9 16 gig RAM. Oh my goodness. Okay. Well, I'm using Chrome here as well. I know some people do get a problem with Chrome. Go Lightstream, Helmet. That's the thing that I'm using. And I'm using it, like I said, I'm using it on this Chrome box here on Chrome OS. I also have used it on my Pixelbook as well. So yeah, really, really interesting. So yeah, we're going to talk about functional programming techniques. Last week at SAP TechEd 2019 in Bangalore, I gave a community talk in the community theatre, superbly organised, by the way, by one of my colleagues, Menina in the community team, and it was on writing what I call solid code, solid state code. And what I meant by that was using functional programming techniques to write code at a high level. You know, this whole idea of describe what you want rather than how you want the computer to work it out for you, and write code such that when you look at it, it's not moving, it's not sort of writhing around, and it doesn't look as though it's suddenly about to change from underneath you, right, or modify data from underneath you. So that was the subject of the talk, and we took some data from what's it called, Northwind, because everybody knows Northwind, it's all very comfortable, and we looked at how how one might write it, quote unquote, normally or traditionally. This particular thing that we want to do, which was to take the products, take some products from Northwind and take out the ones, or identify the ones that have been discontinued. There's a property that says discontinued, it's a Boolean property, and then reduce the price and then put those into, have those in an array ready for putting on sale, right? So really, really simple requirement that allows us to concentrate on the code. So Mahesh says that we did the session in the Chrome console. I really love the console in the Chrome developer tools. It's always been really good, but with the recent versions of Chrome, late 60s, 70s onwards, there's been some beautiful features, including what I'm calling eager evaluation. I think is a different term that they use, but anyway, we'll see that. Chris, when code changes shape in front of you, isn't that called polymorphism? Perhaps, Chris, perhaps, but let's not go there. I mean, obviously, Chris is making a joke. It isn't polymorphism, but I quite like that rather erudite question there from Mr. Chris Whaley. Exactly. So in fact, that reminds me, I've got some things to share with you. Thanks, Srikanth. I've got some things to share with you that I shared in UI5Con, the one in St. Leonard, and also the one in Bangalore that I did remotely. So I've got a couple of documents I want to share with you. We'll do this. We'll go through the session that I did twice, it was, in TechEd last week. And then we'll move on to something that Ronnie posted a tweet about. It was something to do with making a more performant approach to finding a record in an array. When I say a record, I mean basically a map. It's like open curly braces. You've got properties and values, property value. That's a record. It sounds really old-fashioned when you say record. If you wanted to find a certain record in an array, then according to the value of a particular property, then of course you've got to search all the way through, and it's not very efficient. So why not transform that array into an object? Now, sometimes I use the word map because I think map is a more correct term, but again, terminology is another question altogether. So if I say map, I might be referring to the map function, but I might be referring to an object in curly brackets, so a map object. So turn it into a map where the keys of the map are the values of those properties you want to that property you want to search on. So we'll look at the tweet, but before looking at the code in any detail that was in the tweet, we'll build one ourselves so we understand it. And then finally, in relation to that tweet, Ronnie's tweet or retweet, there was a link to this code sandbox, which I've never seen before, actually. It's really cool, that described also some more functional programming stuff to do with, structures of data. So we'll have a look at that just to make sure we all understand it. Yes, thank you, Srikanth. So that's one of the, I got some awesome folks here on the live stream, as usual. So that's the tweet that Ronnie mentioned. So Ronnie's posted it in the chat, and also Srikanth, thank you. That's one of the documents I wanted to share, but super awesome that you've posted that already. Brilliant. Kishore Gokara, I was there in Bangalore TechEd at 2019 at 31. Awesome, and it's great to see you on the stream. Brilliant. I really enjoyed the session. So let's start. Now I've got, it says here, I'm actually connected to Lightstream. There's like a remote control. I've got it on my tablet because I thought my tablet would go to sleep sort of less frequently than my phone. But let me just go here It says attempting to reconnect, so that's a bit of a fail, isn't it? But anyway, it doesn't really matter. No support application. Oh, never mind. So send to live. I'm gonna switch now in my Lightstream control center. Oh, there we go. Right. I'm gonna try and switch now. I'm gonna switch using this one. You are now live. Yes, I know I'm now live. So I'm gonna click on that and see what happens. Theoretically, you should be able to see. Yes, my screen. So let me know, please, in the chat if you can now see my screen. I'm going to minimize this because it gets very, very Inception-like. Double sound now. Double sound, camera. Audio feedback, background. Default mixer. Alert box, chat box. Hold on. Let me go to main here. Yes, okay. I've got two. Delete that one. Send to live. Okay, my broadcast has now been. Oh, thank you very much. Thank you, folks. Thanks for looking after me as usual. So there we go. Right. So let's start. By the way, I've got my SAP Coffee Corner radio podcast mug. This is what I was going to show you. Basically, I think you can see my video in the bottom right hand corner, but this Lightstream sort of remote control, which is just a web browser page, and it's got the scenes that I've defined. And I've just saw also Sai Naresh, you were also there, TechEd 2019. Awesome to have you here as well. Brilliant, welcome. And Kishore and Naresh, yes, great, good to see you folks here. So let's start. So what I'm going to do is I'm going to bring up, in fact, episode 43, these are my things here. Oh yeah, what I also wanted to show, to let you know was that, as you can see from Eric Wastel's tweets here, there's the advent of code, which if you don't know, it's an awesome set of programming puzzles, some quite hard actually, in a good way, and it's a big tradition now. Lots of hundreds of thousands of people do this. So if you just search for hashtag advent of code on Twitter, and you'll find what's going on. But basically, it's adventofcode.com to go. Okay, so that's that. Why don't I share the other things as well? So programming in a more functional style in JavaScript. The one that Srikanth shared is this one: functional programming for your UI5 apps, hands-on worksheet. And there's also programming in a more functional style, which I wrote a couple of years earlier, but it's still very relevant. It covers map and reduce and filter and things like that. So I'm going to put that. How am I going to share that? I'll share that later. Actually, no, what I could do here is bring up this very briefly and just make that full screen. I can paste that there. Video page, I have no idea what that says there. Perfect. Okay, great. I can minimize that. So that's that. And what else do I want to share? Oh, yes. The other thing, hey underscore, you're doing it wrong. Search for that on YouTube. Awesome. And we'll be talking probably a little bit about this through the course of this live stream. I think Helmut, you're on the stream today. That's great. And I think you use underscore, or was it Lodash? I can't remember. One of the things that I find a little bit odd about underscore or Lodash is that, for me, and also for Brian Lonsdorf, who is the person speaking in this talk here, hey underscore, you're doing it wrong, is the order of the parameters, which prevents you from writing point-free code, prevents you from writing really nice functional programming style code. So yeah, have a look at that video and see what, it's Lodash FP. Okay, so maybe Lodash FP has fixed the problem that underscore and Lodash had. So, I express my ignorance there. Also, I wanted to show you, not play that though. I wanted to show you this, this particular video here. It's on my channel, implementing partition 3 ways in JavaScript and Ramda. I know Chris was on this live stream as well. I will also post this. There we go. There's the YouTube video. I need to pop that chat out somehow. This is if you want some more functional programming goodness, go there. And in fact, if you haven't subscribed to me on YouTube, please do subscribe. Maybe I'll make 1,000 subscribers by the end of the year. It doesn't sound very much, but it'll be make me very happy. So please subscribe to my YouTube channel as well as the SAP Developers YouTube channel. And I think that's it. Yes. So let me go now to where we wanted to go to. Okay. So Helmut, you're saying it's got more functionality than Ramda. Oh my goodness, more functionality than Ramda. I mean, Ramda's got a ton of stuff, almost too much stuff. Yeah, 10 more needed, Robertino, 10 more needed, exactly. It's almost got too much stuff. So I'm picking this services.odata.org, and this is what I did in the talk, because we all understand what this data is. It's basically an array, a little bit bigger, an array of records where each record is a product. Okay, the product's got a product name, for example, it's got a unit price, and it's also got a discontinued Boolean property, right? Whether it's discontinued or not. And there are a few discontinued products in this particular set. If you go down to the bottom here, you can see that there's only 20. It uses paging here. We're not going to grab them all. We only want a few anyway, so that's fine. So in fact, what I'm going to do is I'm going to grab, using my Vimium keyboard shortcut mechanisms, I can just jump to that link there to go to the JSON viewer raw view, so I can copy that raw data. And now I'm going to open up, not a incognito window. I'm going to open up a Chrome Developer Tools console. Okay, so let me go back to this here, and I'll also minimize that. So I can say, for example, data equals that, just to grab that data. Okay, so now we've got something in data, right? And I'll assign. I'm going to do it exactly the same way as I did it in the talk, so that people who were at the talk can sort of follow along. Products equals data.value, right? Notice that it's not data.d as in OData v2, but that has changed now to value, data.value. So there's our products. In fact, if we say console.table, we can see the products. These are all the records. So the first product is Chai, second is Chang, and so on. And if we also look, in fact, at the products sort of in the normal way, we can see that, and I just happen to know from doing it last week, that one of the products that's discontinued, we need to keep our eye on, is this Chef Anton's Gumbo Mix. You can see that it's discontinued. Discontinued equals true. And the price, the unit price of this product is $21.35. I guess it's dollars. I don't know. It doesn't really matter. So that's one of the things that we want to capture and also reduce the unit price and end up with, the items that are for sale, as it were, trying to get rid of. So let's do that in a traditional way. Let me know as well, please. Just let me know in the chat if this is big enough. I'm running this 4K monitor at 720p, as in 1280 by 720. So the screen is massive here. But it also means that there are fewer artifacts when encoding, because there's no scaling down from 3000 whatever it is to 1280. So if I were to want to create a list of these products for sale, sale items, let's just create an empty array. I'm not going to bother for this stage about declaring it with var or let or const. Let's just focus on the task at hand. So we've got our sale items array, which is empty at the moment, and we're going to go through the products and find the ones that are discontinued and reduce the price and put them in this array. So you would all are I equals 0, I is less than products dot length, I plus plus. So this is a traditional, fairly standard thing that you would see everywhere. Okay, we're iterating, we're creating this variable. We're using the variable to iterate through the product by working out and incrementing this variable. So things are changing already, things are changing, incrementing this variable, and then using that to grab the particular product each time around the loop. So the first time around the loop, obviously it's going to grab products of 0, then products of 1, and so on, and then capture all the products or do all the products. Then we've got if product dot discontinued. I mean, let's just do it really, really sort of verbosely. We don't obviously need to equals true, because product.discontinued is evaluated, would be evaluated to a Boolean anyway. But then let's just go for it like that. Notice, by the way, I'm just pressing enter. If you're not familiar with the Chrome Developer Tools console, which is awesome, as I've said, it now is pretty intelligent in terms of knowing whether you've finished typing in your stuff. So I just pressed enter there, and it's not said, oh, this is syntactically incorrect, because it knows that I've just opened a block here and it's waiting me to close the block, which is really nice. And it will also indent and dedent appropriately. So we want to reduce the price. So let's reduce it by 10%. Product.unit price equals product.unit price times 0.9, right? Okay, really simple. By the way, I'm deliberately not putting any semicolons here. There's only a very, very few places when you really need semicolons, and I don't like semicolons in JavaScript, at least. So there you go. And then what we want to do is a sale items.push product. So push that particular product record where I've modified the unit price onto the sale items. Okay, so it looks fairly innocent. It looks fairly innocent to an extent. Let's just press enter again, and then there we go. How nice is that, right? So that looks fairly innocent to an extent. However, and as I said last week, looking at this sort of thing makes me a little bit nervous these days, because things are moving all the time. We're iterating around this array. We're actually telling the computer how to work through a list. Why do we have to tell the computer? Sounds like a kindergarten class. Why do we have to tell the computer how to iterate over an array? It's just like really, really low. It's almost like machine code assembler level stuff. Why are we having to tell it how to, have a variable that's incremented and blah, blah, blah. Okay. But also we are changing things explicitly, but also, as we'll see, we're changing things implicitly. So anyway, we've done this. That's run. And as you can see, and this is this beautiful eager evaluation. What do they actually call it? Eager evaluation is on. I was right. So a sale items, we've got 3 items, and I know that, I think you will also know that the ones that were there last week, there are, in that 20, there are 3 that discontinued, which is a nice number to look at. So why don't we have a look at those 3 items? The first one should be that gumbo mix. Yeah, perfect. And there's another couple as well. So that's great. We've managed to find the products, and we've reduced the price. Now, the price is, subject to the classic sort of JavaScript foibles, shall I say? What word shall I use? JavaScript is notoriously odd in some floating point calculations. And so what we'll do instead is we'll modify that for loop so that, we'll just round this up. Okay, so it should be 19 or 1921 or whatever. Let's just round it to the nearest. So let's round up to 19. So why don't we do that? Okay. So all I want to do here is say math.round. Okay, perfect. So that should be okay, right? So that's the standard problem with all. Yes, it is standard. Yes, thanks, Grace. It is. Not to be too unkind on JavaScript. I'm trying to balance out my view of JavaScript, because I do really like JavaScript as a language. So I can't be completely effusive about it. I've got to find a few issues with it. But as it's almost the holiday season, my grandma bought me some mini mince pies, so I'm going to eat one up now. My grandma's 99. I'm going to go around later and take her to the shops. Just thought I'd share that with you. Maybe she'll buy me some more mince pies. No, just kidding. Okay, so let's run this. Great. Okay, so hopefully our unit price will be now rounded to 19 for the gumbo mix, for example. So let's look at sale items. Now, first problem. Why all of a sudden does our sale items have 6 items in it and not 3? We don't want 6, we want 3. Okay, so our sales items array is completely screwed already, right? And if we have a look, in fact, let's console.table that thing out, a sale items. And we can see we've got the gumbo mix, Chef Anton's gumbo mix there. We've got a nice rounded set of prices here, unit prices, but they're wrong. So why is that 17 now and not 19? And why is the first one that we put in there You know, the first 3 and then the second 3, which is bad enough, right? But worse, it's now 17. If we were to run that again, actually, we didn't do this in the thing, but if we were to run that again, we've now got 9 items in the array. It's now gone down to 15 for every one. Okay, so this is great. This makes me super scary. It makes me super nervous about code that is moving around. You know, it's the opposite almost of solid, the opposite of solid state. It's liquid, fluid. And the thing is, this is only a really small example, but I'm already pulling the rug from underneath my feet. You know, I'm tripping myself up because I'm modifying things that I'm not expecting to be modified. And I'm going to come back to it later, expecting it to be in a certain state, but actually it's in a different state. And yeah, as Chris says, the joys of non-idempotent code. Well, actually, being a classics scholar, idem is the same, and potent is power, the same power or the same effect. Idempotent, I'm pretty sure, means it has the same effect each time. So, for example, get in HTTP, get is idempotent. Put is idempotent because you're replacing something. Delete is idempotent. So you can have read-write functions that are idempotent. Side effects is what we don't want, and the joy. This is really the joys of code with side effects, and we don't want side effects. One of the things that we talked about last week in the call were the beauty of higher order functions, which we're going to come to, the beauty of immutability. And what we're doing right now is completely not immutable. It's mutable. We're changing things, right? It's really, really scary. And this is the source of so many bugs. Okay, so what we want to avoid is bugs or are bugs. And therefore, by writing more solid state code, we can sort of, reduce the surface area where bugs can exist, because if things don't move, things can't change. Anyway, as an old colleague used to say as well, or still says, this is bad enough, but it's even worse than it appears, because we've not only changed the prices of the other records in this A sales items, but if we go back to products and have a look at products, our source data, our source of truth, we've completely screwed the unit price there as well, right? It's crazy. It's absolutely crazy. So that's, we do not want that. So what we want is something that's more solid state, something that doesn't change anything. And for that, we're going to use some functional programming techniques. So by the way, how are we doing so far? Are we all okay? Can you all follow along? I hope you can. I think it should be okay. Let me know how it's working from a stream perspective generally. This is the first time I'm doing a regular hands-on SAP Dev live stream with Lightstream. So there we go. So I think I had one slide describing last week. One slide describing the different functional programming techniques or things that I want to cover. One of the things, thanks Hunter Gatherer, thank you very much, easy to follow, that's great, thank you. In fact, Chris, as my partner in crime from a functional programming perspective, Chris, I'm going to ask you to write these things down, thanks Ricardo, in the chat so people can see them. So Chris, what we're going to cover is higher order functions. So that's one thing to type in the chat. Another thing we're going to cover is sort of reuse and chaining of functions, So higher order functions, reuse and chaining of functions, partial application is another thing we're going to look at. And generally, we're going to look at immutability. So those 4 things. I've forgotten the first one already. Higher order functions, reuse and chaining, partial application, and immutability. So let's start with higher order functions. A higher order function is a function that can receive or receives as an argument, or one of its arguments, or the only argument, a function, and or can also, as output, produce a function. Okay, so effectively, think of, thanks Chris, brilliant, what a superstar. effectively the thing to realize is that functions in a functional programming language are first-class citizens. You can assign a scalar to a variable and pass it around and do things with it, pass it to a function. You can you can assign an object or an array, or those sorts of these sorts of data structures. But in a functional programming language, in JavaScript as well, because JavaScript has multiple paradigms, including functional, functions are first-class citizens in that they can be assigned to variables and passed also into function calls and be received as output from function evaluations. Okay, super important concept to get in your head. So there are a number of built-in higher-order functions. We're going to just use the built-in higher-order functions. We're not going to use Lambda today, or maybe we'll later. We're going to use the built-in higher-order functions to do the same sort of thing. Okay. You've all, I'm sure, heard of, and I cover them in the documents that I've shared and Shrikant have shared on the chat, the sort of the triumvirate of functions, map, reduce, map, filter, and reduce. Okay, I'm sure you've heard of those. There's also other functions in that family called like find, but people usually refer to these sort of three functions as a set. You'll see actually, and once you start digging into this a little bit more, that in fact, all you need is reduce. Reduce is the the mother of all functions, and map can be implemented and usually is implemented with reduce. Filter is implemented with reduce. Find is implemented with reduce. Reduce is just the most beautifully amazing thing, and we're going to do reduce today. In other languages, and other functional programming languages, it's called fold or fold left. The way that this reduce works. And I'm sure if Fred were on the chat, I'm not sure whether Fred is around, but if Fred was on the chat, he'd also agree with me here that reduce is a very beautiful thing. So the idea is that we can use one of these reduce functions, filter. We can use one of these higher order functions, filter, to first of all filter down the products to the ones that are discontinued. And the general idea, or the way I think about functional programming, is I like to build small pieces and join them loosely together. Small pieces loosely joined, build little building blocks, functional building blocks that do one thing, do it well, sort of a Unix philosophy. And then put them together, compose them together and use them in chains and so on. So let's just do that first of all. So we needed to identify whether, whether a product, whether a product was discontinued. So let's define a function. Let's say is discontinued. I'm using the is sort of prefix on the function name to signify to myself and to other people reading the code that this is probably going to produce a Boolean output. Okay, a Boolean result. Functions, by the way, again in the functional programming world, functions that return a Boolean, true or false, are often referred to as predicate functions. Okay, and they're used. They're very important in sort of the higher order function game. So is discontinued is a variable. Again, we're just going to leave the constant let var. We're not worrying about that right now. Is a function is a variable that is equal to is equal to a function. We can tell it's a function with a fast arrow here that takes a single argument or parameter, right? X. I'm quite fond of using X because X is a thing, and then things plural is XS, X's. Some people who know me already will know why that is the case, why I use those. It's from Eric Meyer, X over X's. So X is something that we take in, and X is going to be one of these product records. So X.discontinued. Okay, I'm going to put that explicitly, put the triple equals true, just to remind ourselves of where this came from. Okay, so this is going to be the equivalent mechanism that we used before in that if statement. So let's do that. That's really simple. I mean, it's almost like too simple. Why would we do this? Because then we can write some unit tests for this, and then we can sort of store it and forget it. It's beautifully simple. It doesn't move. It just evaluates, and it always will work, right? So that's nice. So now we can say products dot. I'm going to do a new line with a shift enter, so we can sort of have it all, all nicely readable. Dot filter Now, filter is one of these higher order functions. And again, in JavaScript, there are built-in functions to certain object types. So product is an array, and the array type has a number of functions in the so-called prototype. Okay, we're not going to dig in too much to prototypes, but actually we're going to cover prototypes when we do the next bit about Ronnie's retweet. So there's a built-in function called filter that's available on all array objects. And as you can see here, this is quite new with the Chrome Developer Tools, a really beautiful thing, right? It also shows us the signature of this filter function. So what is it expecting? This arg we're going to ignore. That's what's the word? That's optional anyway. Let's not even get into the whole this thing. We will a little bit in a bit. So it's expecting a callback function or a function. And as you can guess, what it's expecting is a predicate function. So all we have to do is pass it that function, and filter will do the rest. Now, this is starting to look a lot more comfortable already. There's no explicit creation of variables and incrementing the variable values according to how, where are we in the array of products and everything. We don't have to check whether we've gone across the end of the products with products.length and so on. We're not changing anything. So the filter, like its brothers and sisters, map, reduce, and find, and so on, I like to think of them as functions that have built-in list machinery. Okay, so filter knows how to iterate over an array, and what it does is each time around the array, it takes an item and it passes it to the function that we've supplied, i.e. in this case is discontinued, evaluates that call, and then ones where the evaluation of this predicate function called with the individual item, where they evaluate to true, find their way through, and the ones that evaluate to false get kicked out. So that's why, it's obvious, right? We know this even without the explanation, just by guessing, right? So there we go. We get the Chef Anton's gumbo mix. In fact, I've just realized this is still going to be, because we clobbered products before, didn't we? So products is still unit price 15. So why don't we just go up here and get to the part. There we go. Let's just reset the products. Products equals x.data. Oh, not x.data. What's it called? Data.value, isn't it? Data.value. So now products should be, the gumbo mix should be back to the normal price of $21.35. Okay, good. So now if we do that again, control it there. There we go. We can do it again. And notice as well, already, we're filtering out and we get 3. We do it again. We get 3. We do it again. And we get 3. We're not adding to any array. We're not pushing anything onto an array. So we're not mutating anything. We're just transforming things. So there's our product. There's our gumbo mix, 21.35. Good. So far, so good. So now let's do the next step and change the price. But we want to change the price without clobbering the source. Okay, without clobbering the price in the products array. Now, map is another higher order function, which I'm sure you've probably seen before, which works like filter, as in, it gets the function, the callback function that map takes. Map is a higher order function that takes a function as argument. This callback function is given each item one at a time, and whatever the evaluation of that function produces becomes the value in a new array that's produced. Okay, so if we, let's say, let me just do this differently. Let's just press enter, or how to get out of this. There we go. So if I say, for example, 1, 2, 3 dot map, let's do an inline function, a lambda function here, inline function x plus 1. There we go. So the evaluation of this function that I've passed to map, whatever that evaluates to each time around, in this case, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, for example, that becomes a new array. But the original array stays the same. Let me do that, sum array equals 1, 2, 3. Sum array dot map x plus 1. We've got 2, 3, 4. But sum array has not been mutated. We're not changing anything. We're just producing new things. Okay, so in the same way, we're going to provide a function, and this time we'll write it in line for now. A function that takes something, x, let's call it x again, and because we want to write a couple of statements, we'll put it in a block here. This is, we can have a block syntax for the fat arrow function definition. Let's just complete that so we know where we are, right? There's undefined. So obviously this is producing nothing right now. So we've got undefined, undefined, and undefined for the three things. So let's now start fleshing that out. What we'll do is we'll use some destructuring. This is ES6, the way pulling values out of a map, out of an object, right? And we've got our record object, our product object. So let's say let's product name, okay? And also one of the functions of destructuring is you can actually change the name of the thing. So if we just said product name unit price equals X, what that's doing is it's pulling out the unit price property and also the product name property, which we can then refer to. Let's put that up there. So, it's be nice and neat. Return product name unit price. Let's do that basically like that first of all. Okay. So now all we get is product name and unit price. That's how that works. Of course, we haven't changed the price yet, but also what we can do, and of course, the products is, products, I'm getting too excited. Products is still the same. Okay. We haven't done anything with that, but also we can run that as many times as we want and we still get 3, right? So now instead of this, we can also say, for example, product name, but we want it as the property name. So then we can do, if you wanted to give it a different name, there we go. So product name is now name here. That's nice too, right? That's not functional programming, but it's still very nice. So now what we want to do is we want to change the unit price. So if we have something just like name, and might look a bit weird as well in an object that you're returning, if you just have a single property name, what that actually expands to, for want of a better word, is name : name. So that's really neat as well. So unit price, and let's do it manually here first of all. Unit price times 0.9. Okay, that's our thing before. We probably want the what's it called, the math.round. There we go. So now hopefully, yeah, unit price 19. Okay, 21.35, 10% off, 19 rounded. If we run that again, it's still 19. Run it again. Oops, run it again. It's still 19. Where is it? There. More importantly, we haven't screwed up our source data, our source of truth. That is still 21.35. That's exactly what we want, right? We just want to produce a new array of the things that we specifically want to work on without mutating anything. Our source data behind our head, obviously on that wall there. So far so good. We can tweak this a little bit as well, just to go a little bit more crazy. So what we'll do instead of just doing, let's just have it up there. Why don't we create a function? Because this is calculating something. That's fine. But why don't we just to explore? Why don't we create a function called apply discount? Okay, so we can use this in different places. And that function, apply discount, clearly has to work on a couple of things. It's going to work. We want to pass it a percent, the discount we want to apply. But of course, that doesn't mean anything. What do we want to apply it to? We want to apply that percent discount to a price. Now, we're going to go down the path of partial application, which goes hand in hand with currying as well, but we're not going to dive too much into currying. But, but what we're going to do at least is define a function that is sort of, by definition, manually curried, as in it's a function that effectively takes 2 arguments, percent and the price you want to apply that percentage discount to, but effectively it's curried, as in it will accept the first argument, the percent, and then produce a function that accepts another single argument, which is the price. So if we say apply discount is a function that takes, let's just use the long words for the parameter names, why not, percent. So it takes a percent and produces a function. So a function produces a function, okay, that takes a price. And then we'll say, what is it? Price, and we can have a single line evaluation here, price times math.round, what is it? 100 minus percent over 100. I'm sure you can do that probably a better way, right? I think that's right, isn't it? Yeah. Okay, so we've just defined a function called apply discount. Let me just bring that up there and just do that again, right? So you can see it's at the top of the screen. That function is effectively a function that takes a percent and returns a function that takes a price, which returns the evaluation of this, which is basically that percent. Let's say it's 10%, so it's 90 over 100. So 90 over 100 times the price, 10% discount, whatever. So we can partially apply this apply discount function to give us another function that is more specific for what we want to use in our sale items thing. So why don't we say 10% off equals apply discount 10. So we've now partially applied that function, apply discount, as in we've only passed it one of the two parameters it's really expecting. What has that produced? Well, it's produced another function that we've captured in the 10% off variable. That function is waiting for a price and is then going to make this calculation. The really interesting thing that's going to blow your mind when you think about this a lot is, where is this percent? Where's that? And that is the result of this concept called a closure. Okay, so what we've done here in this definition is we've closed around this percent variable or this percent parameter so that anything produced by this function remembers what the percent was. So now this 10% off function has got inside it a closed over percent value of 10. So now if I say 10% off, 10% off £200. Hold on, what's going on there? 100 minus percent, apply discount, 10% off. What am I doing? Price, math round. You need a new round on that. So wait a minute, 10% off. What have I done wrong there? Price, 200 times, hold on, times math.round 100 minus 10 over 100. What am I doing wrong? Folks, help me out here. What am I 100 minus 10 is, 100 minus 10. Yes, 100 minus 10 is 90. Math.round 90 over 100. Okay, we don't want to round it. Let's just ignore the round for now. I don't want to get into the maths thing here. Apply discount. I'm sure somebody can come up with, I can't think and work out maths in my head at the same time. Let's do that. 10% off, apply discount, 10% off. There we go. That's better. It rounds to 1. Yes, thank you. How embarrassing. Well, actually, it's not embarrassing. This is real life, right? I've no idea what I'm doing. Maybe it's because I didn't eat enough of the mince pie. It rounds to 1. Anyway, so now we can apply this function 10% off to a single value, which is this second value that it's waiting for, the apply discount is waiting for, which is, for example, 200. 10% of 200 is 20, so it's 180. So now, where's our little chain of functions? Why don't we do this, right? Sale price, why not? 10% off unit price. Now, let's have a look at that. Yeah, okay, let's forget the rounding for now. But that's exactly what we want to do. So really, for me, this approach is so much nicer, so much more, or so much less scary, because there's no moving parts. Filter is doing its list machinery, implicitly. Map is doing its list machinery implicitly. There's not even here any parameters that we're passing. So this is sort of, this is part of the style of what's called point-free programming, but let's go there maybe another time. And all we're doing to map is defining a beautiful function that just pulls out a couple of values from this object X and returns something. And again, there's nothing really moving here. We've defined our 10% off as a basis of applied discounts. We've tested those. We know they work. So we can look at this in comfort and say, whew, yes, that's fine. I know exactly what that's going to do. Yeah, Ronnie, thank you. I agree. I do agree. I like the purple heart as well. That's our hands-on SAP Dev color, isn't it? Not significant, not, but anyway. Yeah, I think it is beautiful, right? The way that you can write this sort of stuff, I think is really nice. So that really is the long and short of what we covered last week. So we've covered higher order functions. So filter is a higher order function because it takes a function as its argument. Map is a higher order function because it also takes a function as its argument, which is that thing there. We've covered chaining. We're chaining effectively functions together. So we're chaining filter, and the output of filter goes into the input of map, and then the output of map comes out, and that's the answer. We've looked at partial application, which was a bit crazy, but we can dig into that a little bit more. And we've also hopefully sort of implicitly as well as explicitly covered immutability, not changing things. We can run this, again and again and again and again and again, and we're not adding to anything. We're not sort of increasing the number of records in a particular array. We're not mutating anything. It just is. It's just so much more what I like to call solid state. It doesn't move. It doesn't change anything. So hunter-gatherer, especially working with old ABAP, you find a lot of nested loops that are basically filtering and replacing, and most of the times you are scared to touch. Exactly, yeah. I mean, I know exactly what you're talking about, and not just ABAP as well as other, in many other languages you see that, but it's particularly prevalent in ABAP, yeah. Yes, you could. In fact, we're going to. Yeah, so Chris is saying that I could refactor this as well to include anonymous inner function. We're going to cover a little bit of what Chris is referring to in the next bit. In fact, it's a pattern I learned from Chris. So, hats off to Chris for this next bit. Well, part of the next bit. So yeah, you could do. I do like the let statement though, because it's sort of like the equivalent in Clojure with a J, the language, the functional programming language that compiles a JVM, and also in Elm, which is a functional programming language that compiles the JavaScript. There is a sort of let clause that is very common, this sort of pattern. But anyway, so how are we doing for time? 8:52. That's awesome because I'm going to do this for 90 minutes. It's allowed me to go a little bit slower and explain things a little better. So let me know in the chat as well whether this is this sort of this speed, which I think is a bit slower, whether this speed is working for you okay. Yes, it does. The let does make the code's intention easier to understand. I mean, there is a tendency, and I think I tweeted this particular thing yesterday, there is a tendency to try and make things as condensed as possible with some people. Thanks, Helmut. And that, that's one nice thing, but you want to write something that's easy to understand as well as not moving. Oh, by the way, I've just noticed, just remembered, I'm wearing my functional programming, my latest spreadshirt here, Functor. So maybe in another live stream, functional programming live stream, sort of midweek live stream, we'll look at what a functor is. An array is a functor. I'll leave you to figure out what a functor might be, and then we can cover it another time. But I just love the word functor. It was so nice, I just put it on a t-shirt. And people will come up to me in the street and say, please tell me about functors. Not. Okay, so now to Ronnie's tweet. I'm going to open up this Yes, my T-shirt implements map. Well done, Chris. I knew you'd sort of say something like that, which is true. Exactly, that's what a functor is. So let me just up a new window up here, and we'll go to Ronnie's tweet. Where was it? This one. Well, Ronnie's retweet. So this person called Kyle, this might be bold, but I think every front-end JavaScript developer should have this trick up their sleeve. Assuming your data set is a reasonable size, converting an array to an object can really speed up how fast you find items. Now, there's a code in the screenshot there, which is quite a nice screenshot. Anyway, it's a nice style. But what we're going to do is we're going to work out what that means and write one ourselves without really looking at the code. Your brain's nemesis, here it comes, Ronnie. So let's close that and go back here. We've still got the products, right? So we could use the products as this data. So let's just have a look at the products. It's an array of record. I'm going to use the word record, right? It's an array of records where each record is a product. So and the records have certain properties: product ID, product name, supplier ID, category ID, and so on. So let's assume, for the sake of argument, that we want to find a record given its product name. Okay, so let's say I want to find this product given the name Ikura, right, for example. So, and again, I could start out way back and use a for loop and everything, and if, then, else, and whatever. But I think we already now are able to move on from that to a more functional programming style using higher order functions. And there is a function, a higher order function called find. Okay, so why don't we try that with find first? Find's not bad, but find will iterate through the array until it's found what we're looking for. So let's say we got an array with lots and lots of items in, and it goes all the way through because the one we're looking for is right at the end, in terms of memory. So that's bad. That's what we want to avoid. But we can do that. Let's look at the products.find, and the find is a higher order function, which means that it's expecting a predicate function. Now, interestingly, it's calling this function a predicate function. When we did the filter, it said callback, which is interesting because I would have thought it would have described the function that's passed the filter as also a predicate function. The map function is a callback function, as in the function you pass the map is a callback function, but the function you pass the filter is a predicate function. So I'm wondering why it says callback function there. But anyway, let's not even go there. Find, and a predicate function, as we know, is a function that takes an input and produces a Boolean output. So let's define the function in line. A function that takes an X, okay, and find, of course, passes each of the items, each of the records in the array each time to this function, and it will stop at and spit out as the output of the find function the record where the predicate resolves to true. So what x dot product name equals, what was it called? Well, I know there's one called shy, right? Okay, I can't remember. There's one called shy. There we go. Products, what was it called? Oh, Ikura, right, let's do that one. Yeah, just for the sake of argument. I also don't like double quotes. I don't know what's wrong with my brain, but it's old age, I don't like double quotes. So there we go, we found Ikura. So it's iterated over that, and of course it's very fast because there's only 20 products, right? Nothing. But you can imagine the problem, right? What's happening in the background is the list machinery is going through that array because it's still an array we're processing. So instead, what we want to do is reshape. That's a word I've learned from watching all these videos on APL. It's an amazing language. We want to reshape our data from an array to an object or to a map, right? So we want to reshape it from something that, looks like that to something that looks like that. Now, map is a really good way of reshaping data, or is it? Map is a really good way of reshaping the values inside an array. So you can't reshape the outermost thing with a map. A map or takes an array and produces an array. Filter takes an array and produces an array of filtered objects. Find takes an array and produces a single item, and so on. So how do we do this? Oh, Chris, you just said something. Yeah? Filter explicitly needs a predicate function, whereas map or reduce simply require a function that performs. Exactly, which is the reason why I'm asking, or we're wondering, 1, 2, 3 dot filter, why the little type signature up here doesn't say predicate like it does for find. Maybe that's a bug. Anyway, so what am I saying now? What we're doing? Oh yeah, so we want to reshape something that looks like that into something that looks like that. Now we said earlier on that reduce is also part of this family, and reduce is the mother of all functions. And there are with reduce you can implement all of these other higher order functions. You can implement map, filter, find, whatever. So we're going to use reduce. Now, a lot of people think of reduce as a function that takes an array and produces a scalar. Okay. For example, you might want to reduce a list of numbers down to a total. So let's say, for example, 1, 2, 3, and we want to produce the answer 6. Okay, so that the addition of all those. So that's reducing an array down to a single scalar value. And a lot of people use reduce for that sort of thing, but you can use reduce to produce any shaped data, not just a scalar. But why don't we start with this first of all? This is a really simple thing. Let's start with this and go very slowly. We've got half an hour, which is brilliant. We may not get onto the longer thing that you had a question on, Ronnie, as well, but we should certainly do this reduce and do this sort of this reshaping. Let's take our time. So nums equals 1, 2, 3. Let's just do that, right? So we've got this nums thing. If we wanted to produce what these things all add up to, we can use reduce. Now, one of the interesting things about reduce is that, yes, it's a higher order function. Okay, Srikanth, thanks for joining us. By the way, I'm always looking up there because the screen is on my wall showing the chat there. Yeah, catch up the rest of the recording. This is now we're going to cover reduce, and I think it's really exciting. So thank you for joining, and well done on the flip-flap numbers. Those are awesome. So map and filter that we've seen take a function. So map and filter are higher order functions. They take a function as input. And that function, if you remember, is only expecting a single item, a single argument. Okay, let's just do that. So if we say nums.filter x% 2 equals 0, as in which ones are the even numbers? It's 2. Okay, not equals 0, 1, and 3, right? So filter takes a function that takes a single argument, okay, which is the thing, the item each time in the array. Reduce takes a function and that function takes 2 arguments. If you have a look at the best documentation, I would say, let's just do another new window here very briefly. MDN reduce. MDN, the Mozilla developer network, is great. I'm not going to go through all this, but basically you can see array.reduce takes a callback, which itself takes an accumulator and a current value, and also optionally has this index and the actual array itself. And it also takes an initial value, okay? So have a look at that. MDN is the best docs out there, yeah. So the function that gets passed to reduce itself doesn't take a single argument like the functions that get passed to map and reduce. It takes 2 arguments. We'll look at what those 2 arguments are in a minute. But slightly confusing, reduce itself takes 2 arguments. It takes the function, right? And also it takes a starting value for whatever we're going to produce. So if we say nums, we can say nums dot, I'm just going to do one. It might be easier, right? In that, the signature here is also very helpful. So it takes a callback function, and it also takes an I guess that means optional. And why would you not supply it? I guess it defaults to 0 or undefined. I don't know. And it takes an initial value. So why don't we say let's provide a function that, I don't know, adds the doubles them, right? So x function x times 2. Okay, and no, not what am I? Sorry, what am I talking about? We want to add these numbers up, 1, 2, and 3. So we want to pass it a function, and this function, I'm not going to put the names. I will, like a comma x, and produces something, right? And also, and there's our function definition is going to go here, right? And also it takes an initial value. Okay. What we want to do here, and do it as simple as possible, a plus x. Now, it makes 6. If we say here nums equal, let's just redefine nums. Nums equals 1, 2, 3, 4, 5, 6, 21, right? So how is this working? Well, let's first of all rewrite this in a simpler form. Yes, DevDocs is pretty good, actually. I've used that before as well, but I always go back to the MDM stuff online because, I'm always online anyway, and it's really good. So let's go back and rewrite this nums.reduce in a sort of a simpler way, using like an old-fashioned function definition. So nums.reduce, okay, so that's the same sort of thing, right? Accumulator and the item. Okay, so this is exactly the same. And I'm using the word accumulator because the accumulator is the thing that gets passed into the reducer function each time. So it starts off with 0. So the first time around, the first call to this function gets the first item in the nums array, which is going to be 1. So when this function is called for the first time, as in the first item in the array, item is going to be that value 1. An accumulator is going to be the value, the starting value of 0, right? So I said a plus x, but let's just do it longhand. So accumulator equals accumulator plus item. Item. Oops, I meant to press shift return if I'm inside that it doesn't know I want to continue. Return accumulator. So that is the longhand equivalent of that thing at the top. Hopefully that sort of helps a little bit understanding. If you've not seen or used reduce before, that's what's happening in the background. So each time round, for each of the items in the nums array, 1, 2, 3, and so on. Let's go back to just 1, 2, 3. Just keep it simple. So each time around, the first time around, the item is 1 because that's the 1 there, right? And reduce will then take that item, pass it as the item parameter, as in the second parameter to the function that's passed to reduce. It will also pass the starting value of 0 to the accumulator, as in we're accumulating, we're building up, right? Something. And then we can do whatever we want. So we can just add that item. In our case, we're adding the item to the accumulator, numeric addition. But what we've also got to remember to do always is the output of the function execution or the evaluation of the function becomes the value for the accumulator for next time around. If we didn't return this, if we didn't return the accumulator, it would be undefined. The output of this function call with the first item would be undefined. So it's always going to be undefined past that, right? So we've always got to return the accumulator. Now, in this definition, there's no return statement, no nothing. And that's just because in ES6, a fat arrow syntax-based definition of a function, if it's a single expression with no function block, curly brackets, you don't need the return statement. Whatever is evaluated in this single expression is returned as a result of that function. So that's what this succinct precise, small-looking function definition does. That is exactly the same as that. Now, the interesting thing is that we know already that we're taking an array and turning that array, transforming it, I suppose is the word, I don't know. Anyway, we're turning it into a scalar, 6 in this case. We can also, if we wanted to, let's say, why don't we get the list of product names? And why don't we use map for that? Okay, I mean, just by the way, products dot map x dot product name, right? A really nice, easy way of getting all the product names. Great. So we can now iterate over that with reduce. This is a stupid example, but let's do that anyway. With reduce and say, I'm going to use A for accumulate and X for the item, for the thing. We can say, for example, I don't know, A plus a space plus X. And then the starting value is, an empty string. So all I'm doing is concatenating these things together. It's a bit stupid because, of course, the starting value is this empty space. So we get nothing empty space. Let's just press enter. We get nothing empty space as a thing. Okay, but for the sake of argument, that's what we're doing. So here we're taking an array of product names there, and we're making it into a string. Okay, great. So reduce can take an array and transform it into anything. So what we want to do, going back to the original tweet, is transform an array into an object, into a map, right? A curly bracket thing. And we now know that reduce can do anything. We can do that. By the way, if you did want to produce something like this anyway, you could say, for example, products.map, and then you just join instead, right? Obviously, right? That's what you want to do. Again, join is another beautiful function that works on arrays, right? Anyway, so let's go back to products, and the products look like that. And let's say we do want to produce something that's keyed by the product name. So with that knowledge now, are you still with me, by the way? Let me know that you're still with me. With that knowledge now, let's do it sort of manually first of all, and then we'll create a function that does that automatically. So product.reduce, let's put the dot reduce down here. It takes a function which takes an accumulator and the item, X, and it's going to do something. Let's put it in brackets, why not? In curly brackets. And the starting value for this reduce call is not a scalar 0. It's not an empty string scalar. It's an empty object. Okay, you could also say new object or something. Anyway, or new map. You use the map, the S6. So now, what do we want to do here? We want to say A, and then A, the first time around, A is going to be this empty object. A, x.product name equals X. So what we're doing each time around is we're adding a new entry to the A map here, this A object, where the key of that entry is the name of the product, and where the value of that entry is the actual whole product record. Let's see if that works. Oh, Chang, what? Undefined? What am I doing here? AX. Oh, ha 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 ha. I've done what I said we shouldn't ever do. Forget to return A. Okay. That was almost like deliberate. It wasn't deliberate, but it was almost deliberate. So we're saying reduce over the products, pass the function which is there. That function takes the accumulator, takes the item. The starting value for the accumulator is an empty object. Adds a new item to that object where the key is the name of the product of the X and the value is the whole X. So we produce that. So now we've gone from an array of products to a map of products where the key is the product name, and the key resolves to the value of the actual thing there. Alice Mutton, for example, there. Alice Mutton, da, 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 da. So we can now say, let's assign it to something, by name equals by name, well, it's Chan, for example. There you go. So that is what this tweet was all about. Now, it's all what this tweet was all about, but a little stage further. Why don't we make this generic? Okay. And why don't we also add it to the prototype of the array object? So we got the array dot prototype dot, and all the different functions that will work on an array are all in so-called prototype. Filter, find index, flat map. Flat map? Well, I didn't know it did have flat map. That's cool. And so on, right? And there's going to be, sort, slice, blah, 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 shift, etc. Pop, push. We can add our own. Okay, JavaScript's beautiful, very flexible. Let's start by doing something really simple, like I'm just going to make something rubbish up. So some random thing. Okay, so we're going to add a function to the prototype of the array object. So basically, some random thing will be a function available on all arrays. And that function can take any number of parameters. I'm defining it using the old style function keyword because we need to refer to the instance of the array data via the this parameter. And with the fat arrow syntax, there's no concept of this. So that's why you'll see this sort of definition for prototype functions using the old function keyword, because there's no this if you don't use the function keyword. So why don't we say, I don't know, return 10. Oh, why don't we say this dot length times n? Okay, it's a stupid thing, right? But there we go. We're saying take the length of this, and this will be whatever the array is, and multiply it by the thing we pass. Okay, just so we can see we can pass function, pass data. Okay, so we're now, if we say 1, 2, 3, 4 dot some random thing and pass it, 5, for example, 20. So this dot length is 4 because there's 4 things in there, and we've times it by the n that we've passed there, which is 5. Okay, we can do it. You can do all sorts of random things. Console.log banana, and then if we call that now, we get a banana in the console log. Okay, so we now know how to extend the standard array object with a useful function. And with the knowledge that we've already gained from doing this, we can make it more generic. So why don't we say, well, let's bring up, let's do it. Okay, so array dot prototype dot make object on, and then equals. So we want to be able to say, I've got an array and I want to make an object based upon a certain property. So we've got a function, and we're going to expect the thing that's passed to this function to be a property. And then we'll say this dot reduce, let's do a return this dot reduce, and we know that a reducer takes a function that takes an accumulator and an x and then does something, and the initial value for that reduction, let's call it, is going to be an empty object. Return this dot reduce. Yeah, okay, that should be fine. Now, what we want to do is we want to say a of prop equals x. I think that's right, isn't it? This dot reduce, yes. See if that works, first of all. There's no point in explaining this if it doesn't work. So if we say, for example, products dot make object on product name, Oh, it's not quite right, is it? Hold on, what's going on? What am I doing wrong here? This dot reduce property, make object on. We've got the property, we've got the array. Product 20. Ah, wait. A dot prop equals x. Ah, wait. Ah, yes, of course. I'm tripping myself up here. We need to return it. Otherwise, we're not getting that whole thing. Let's try that again. What's going on? What? A dot prop x return a. What's going on here? I wrote it down here actually. X. Yeah, that should be right. Return this dot reduce a. What am I doing wrong here? Let's start again. Make object. So this dot reduce. Reducing that. We've got plenty of time. Yeah, no rush. It's a function that adds x to. Oh! Of course. What a fool. Why didn't anybody tell me? Yes, thanks, Ronnie. X prop. Right. So Rodney's almost. X prop equals x. What I'm going to do is I'm going to look at this thing here. We'll bring it up to DJ. Oh, wait a minute. What's going on? There. A x of prop equals x. Yeah, that's right, isn't it? Reduce. That's the one. We want to return that anyway. What am I doing wrong here? Let's just help ourselves out by putting some spaces in here. Oops. Return. This dot reduce. This dot reduce. Ax. Okay. And we want here a of x. See, right. Hold on a minute. What's just going on here? X of prop, return x. Return a. That should be right. Unless x of prop. Well, I just want to include this just in case. Make it on product name. Product name's still there, isn't it? Product name. All right, let's do it manually. So if we say, for example, products dot reduce x ax of prop. Well, let's say x of a x dot product name. Name equals x. Return a. And the starting thing is that. Hold on. Object. X dot product name. I think I've screwed products up somehow. Okay, let's just do this again. Products dot equals data dot value. Yeah. In my, yes, I think in my rambling, well, in my ramblings, I've screwed up there. So that, yeah, okay, that's fine. So now if we go back, control up there we go. Okay, so let's just do this again. Let me also go to the original one. There we go. AFX of prop is there. There we go. It does work. So basically, so I had forgotten the it was X of prop, not prop, obviously. So Ronnie, we were right there. I think I've screwed up something. So in your tweeted example, yes, all yes. So I want to introduce that now, Chris. That's perfect. So there we go. So that there, make object on. Why don't we make it on? What else have we got here? Products. That's really the only sort of meaningful thing here. But we've got the, I don't know. We've got the product ID. It's a stupid example, but products dot make object on product ID. Is it capitals? There we go. So we've turned the array of products. Back on track. We've turned the array of products into an object where the key of the object is the ID of the product, and then the value is the whole product record. Right. Now, what happens if we specify a value for the property where that property doesn't exist? We get all sorts of weirdness, right? Yeah. So that was, and this is what Chris is referring to, that was where I can use, let's just go and redefine this thing here. I can use a third optional parameter that reduce passes to the function it's given, which is the array index. So I'm going to say, I also want to take the index. If you look at the MDN, it'll say the reduce function is given the accumulator, the item each time, and also the index of the item in the array, and also it's given the array as well as a thing, as a whole, the whole array each time if you want it. I don't want that. I just want the index though, because then I can say, well, we're going to use either the property of X as the key into the accumulator, or if that is undefined, we'll just use the index. Okay, so at least we don't break, at least we get an object with some sort of, usable index. Let's do that. So now, if we say make object on foobar, we get a nice thing where the actual key is the index of the item. Now, in the final 3 minutes, one thing that I had on the tweet that we haven't covered is this thing here. In order to get rid of the need to have a block here, this is one thing that Chris is very keen on. This is where I learned this from Chris. If you want a single expression and no block, curly braces, and no sort of, semicolon, return this, which is a little bit pedestrian. What you can do, let me just put this on a separate line here so we can see. Is say, have an anonymous function which takes an argument which we're not interested in, right, put some spaces there. Let's just run that instead and see if that still works. Yes, it does. Make an object on product name, Chai, Chang, etc. Yeah, right. What this is doing, and I think you want to stare at this for a bit, this is defining, so this is a function, our reduce function is that. The body of the function is the inline definition of a new function that all it does is takes an argument and completely ignores it. That's sort of like, the convention to say, well, there's an argument, obviously it's going to be passed, but I'm not interested in it, so I'm going to use an underscore for that argument position. And produces and just returns A. A, we've already closed over here because A is there, A is passed to us. And then what's passed, So we immediately invoke this inline function definition with this value here. Okay. So that what happens is that this value is evaluated, passed to this function, which spits it out. So this is almost like the equivalent of doing a return. And you'll see this in some slightly more advanced, slightly more terse functional programming code blocks. It took me a while to get my brain around this, but I thought I'd introduce it anyway. And I know, Chris, you like it. I do too. And this sends us on the path to single expression functions, and if we're not careful, we're on the slippery slope down to lambda calculus. So we better be careful because that's like mind-blowingly awesome. Anyway, it's 9:30. I said I'd go for 90 minutes. It's 90 minutes exactly. Hopefully that's been okay. I mean, I've really enjoyed being able to go a little bit slower and cover the things in detail. Was that what? In fact, Ronnie, you just said, was that okay in terms of the explanation of reduce and how to add prototype functions onto the array thing? If so, let me know. If not, also let me know. But hopefully that's an explanation. I guess that it's going to be similar to that tweet. Oh, where's the tweet? There it is there. It's going to be similar to this code, right? What does it look like? Yeah, okay. Interesting. So the way that this guy has done it is that he's defined a function, a manually curried function. What they haven't done is added it to the array prototype. But I think this is nice anyway, right? But it's the same sort of thing. Return array.reduce, blah, blah, blah. It's exactly the same. Okay, they're doing it, a slightly more pedestrian way, which is what we did at the start. So there we go. Okay, thank you so much for joining on a cold Tuesday morning. Thanks for really making it interesting on the chat. Still a little bit confusing, but a bit clearer. That's good. I'm not expecting anybody to suddenly have a revelation. So yeah, we can do some more of this if you want. And have a lovely Tuesday morning, afternoon, and evening. And I'm going to turn off. I'm going to see if I can stop streaming on my thing here. Attempting to reconnect. That's not great, is it? But anyway, I can go switch back to. Oh, there we go. Start end stream. Okay. Goodbye.